All right, partial fraction decomposition. Now, the reason this is done is because look at how big this mess is, right? And we know in math, it's easier to work with stuff when it's smaller. So let's try to make this smaller. And what does that mean? That means let's find a bunch of little fractions that add together to build this big thing. And that's our goal. So it starts off with understanding that you got to factor the denominator. Oh my goodness, it's an x cubed. And so one of the things I would try with x cubed is there's four things I could factor by grouping, right? So I could be like, hey, pull out an x squared and you'd be left with x plus 13 and pull out, I don't know, what do they have in common? Definitely a 5. So 5 and you'd be left with 11x plus, oh, these already aren't going to be the same. So that was a bad choice. So I can't do that. All right, let's erase that. Another idea. Back in like chapter 3 or something, we did synthetic division. So interesting. This will bring in synthetic division, I would think. So if I'm going to do some synthetic division, I have the numbers 1, 13, 55, and 75. And you might notice they're all positive, so I don't think I'm going to try any positives because they'll just keep getting bigger and giving me an upper bound, if you remember that stuff. If you don't, you just go ahead and plug away and try. So the first thing I would try probably is, factors of the last over the factors of the first. So factors of 75, which is 1. So I'll try that. So 1, -1, and 13 is 12. -12 and 55 is what? 30, 43. And -43 and 75 is 32. Oh my gosh, they're all positive. It's still an upper bound, so there's nothing to test that would be bigger than -1. All right, 2 doesn't go in. 3 goes in, so let's try -3. So 1, -3 is 10. -30 is 25. And oh my gosh, -75 and 75 is 0. I got one, kids. All right, that's super important. -3 works, right? Which means that x plus 3 is a factor. Well, it also tells me that x squared plus 10x plus 25 is the other factor. And I know that factors because it looks familiar as x plus 5 and x plus 5. So that would be x plus 5 squared. Holy mackerel, 2 sets of linear factors, right? Linear meaning they're x to the first power. All right, so now I can rewrite this problem. I can rewrite this problem as x plus 3 is one factor. And then another factor could be x plus 5. And another factor could be x plus 5 squared. And that's the scary part. Anything that has a multiplicity, all these vocab words and stuff, anything that has a multiplicity, we're going to have to represent however many times it has that multiplicity. So it had a multiplicity of 1, multiplicity of 2. There they are. All right. Now the fun part, you get to bring in some variables and you'd be like, all right, well, this is variable A because there's some number on top of this and it has to be 1 power less than the x value. This guy, 1 power less, would be B. And this, believe it or not, even though it's getting squared, that's multiplicity. We'd ignore the multiplicity and we say, hey, this is x to the first, so we only need a C. So there you go. There is my A, B, and C. Now, what does that mean? Well, that means I would like now to get a common denominator so I can ditch all these denominators. So you might notice this guy needs an x plus 5 squared, right? He needs 2 of them. And this bottom needs an x plus 5 squared. And then all of a sudden, they have this denominator right here. This guy needs an x plus 5, and he needs an x plus 3. Oh my goodness. But at least he's the same, x plus 5 and an x plus 3. And then this guy just needs an x plus 3, and he needs an x plus 3. And the good news is all the denominators are the same. So what it means an equal sign is the two sides are equal. So the bottoms we know are equal. That means the tops are equal also. So that's good news, right? All right, how do we use it? Well, let's figure some of this stuff out, right? Like I might FOIL this out and get x squared plus 10x plus 5, and that's still, 25, and that's still multiplied by an a. This is x squared plus 8x plus 15, and that's still multiplied by a b. And this is just, hey, cx plus 3c. That was kind of nice. All right, let me make this look a little prettier by distributing the a through. So I have ax squareds plus 10ax's plus 25a's. And now the next one, plus bx squared plus 8bx plus 15b. And then last but not least, the cx plus 3c. Now we know that's equal to negative 3x squared minus 27x minus 62. Now the fun part, right, is just kind of this obvious observation that you're like, I have no idea what a, b, and c are going to be. That's a very difficult thing to figure out. Well, you know that you can simplify this down. This is chilling in front of x squared. This is in front of x squared. And that's it. And this is in front of x squared, and those two sides are equal. So I know that negative 3x squared has to be equal to, I'm going to here, I'll do it, ax squared plus bx squared, right? Or if you factor out the x squared, you would have a plus b times an x squared has to be equal to negative 3. So I could just pull that out and say, hey, kids, a plus b has to equal negative 3. And I can do that for each piece. I can say, hey, look, I know that negative 27x has to equal whoever has an x in them. So that would be this guy, 10a. Nope. 8b plus 8b plus c. Plus c. All of that has an x in it. So 10a plus 8b plus c has to equal negative 27. And then last but not least, I know this guy, negative 62, is equal to anybody that doesn't have an x. 25a, 15b, and 3c. And lo and behold, I have a nice, what would you call it? A system of equations? Are you kidding me? So this is taken along like every chapter we've worked on. Is that a 15b? I think so. 15b plus 3c is equal to negative 62. So now I have a system where I would love to solve for a, b, and c, and luckily I just finished a bunch of system stuff, right? And so I'm going to go second matrix, and I'm going to go over to edit. And this first one is going to be, I'm going to just use a augmented matrix. So I'm going to do a 3 by 4. And then I'm just going to put the numbers in 1, 1, 1, 1, 0, negative 3. That's that first equation, right? Oop, notice I didn't get the negative 3, and I caught it. That's huge, because otherwise I'd be very sad. How about 10, 8, 1? 10, 8, 1, and it's not very full. Negative 27. 10, 8, 1, negative 27, and I wish I had my glasses because my eyes are bad. And 25, 15, 3. 25, 15, 3. 25, 15, 3 is equal to negative 62. And lo and behold, I'm going to quit out and I'm going to solve this. Now, what am I going to do? I'm going to go second matrix. I'm going to go over to math. I'm going to go to RREF, or maybe not because of my fat fingers. And then I will go to RREF, which is right there, and I will call up second matrix A, and it will solve it. And lo and behold, it says, because I know how to read it, I probably should leave it up, negative 2, negative 1, and 1. A is negative 2, B is negative 2, and C is 1. So what does that mean? Plug them in, right? A was, if you see before all that mess, it was negative 2 over x plus 3 plus B, negative 2 over x plus 5 plus C, which is 1 over x plus 5 squared. And there you have decomposed it into much smaller, prettier, cuter, wonderful little fractions that, if you added them all together, would turn into this mess. Huh? All right, I'll make another video to do 6, so stay happy.